Imagine running a busy street food stall. Your biggest daily challenge is a balancing act. You need enough food on hand to feed a long line of hungry customers, but you can't buy so much that you're throwing away spoiled ingredients at the end of the night. To master this, you have to track different types of inventory. The first stage is your raw materials, the uncooked meat, the fresh vegetables, and the empty buns waiting to be used. Once you start cooking, those materials transform. The patties currently sizzling on the grill are your work in process, or WIP. They are no longer raw ingredients, but they aren't quite a meal yet either. Then you have your finished goods. This is the fully assembled, wrapped burger ready to be handed directly to the customer. Behind the scenes, you also need cleaning spray, some extra spatulas, and thick paper napkins. These don't go into the food, but you can't operate without them. This is known as Maintenance, Repair, and Operations Inventory, or MRO. Tracking how items move through these stages helps a business, from a single food cart to a global corporation, keep its costs predictable and its customers fed. When we scale up to a massive manufacturer like Top Glove, the essential raw material is liquid latex harvested directly from rubber trees. Their work-in-process inventory looks like this: countless hand-shaped molds dipping into the latex and curing along highly automated factory lines. The finished goods are the millions of fully inspected gloves, packed in the boxes, sitting on warehouse pallets, ready for export. There is one additional stage at this level. When those pallets are loaded onto cargo ships heading across the ocean to a buyer, they become goods in transit, sometimes called pipeline inventory. At a global scale, guessing your inventory levels is impossible. A tiny miscalculation leads to empty shelves or millions in wasted storage fees. To survive, companies replace manual counting with precise mathematical models. Every inventory manager is trying to solve the same two-part puzzle. Exactly when do we place an order, and exactly how much do we buy at one time? If you order massive quantities, you trigger high holding costs. This is the financial drain of physically keeping items in a warehouse. You pay for the floor space, the insurance, the security, and the taxes, all while hoping the materials don't expire. To avoid those storage fees, you might try ordering very small amounts frequently, but that triggers ordering costs. Every single time a truck arrives, you pay fixed penalties, shipping fees, invoice processing, and the labor required to inspect the delivery. This chart shows how those two expenses interact. The ascending line represents holding costs. The larger your order, the more it costs to store. The descending line represents ordering costs. Buying in bulk means fewer deliveries, which saves you money on shipping and processing. Watch this third U-shaped curve appear. That represents the combined total cost. Right at the lowest dip of that curve, where holding and ordering costs cross, is your economic order quantity, or EOQ. It is the mathematical sweet spot for minimizing your expenses. If a factory produces its own internal parts in batches rather than buying them from an outside supplier, they use a nearly identical formula called the economic production quantity, which balances the cost of setting up machines against the cost of storing the manufactured parts. These calculations create a highly specific safety zone. They ensure a business has enough stock to meet customer demand, without tying up critical cash in piles of excess material. In the real world, suppliers often complicate this math by offering steep price cuts if you buy in massive volume. Think of local hypermarkets like Miden, which purchase goods by the truckload to secure a cheaper unit price. To handle this, managers use a quantity discount model. They have to carefully calculate whether the money saved on the actual purchase price is greater than the extra holding cost generated by filling an entire warehouse with bulk goods. True profitability requires looking past the attractive sticker price on an invoice and calculating the total, long-term cost of ownership. Knowing how much material to order is only half the equation. A factory also needs strict rules for timing. That schedule is driven by a document called the Master Production Schedule. The master schedule dictates exactly which final products will be built, the specific dates they must be finished, and the exact quantities required to satisfy current and future customer orders. To execute that master plan, the factory turns to the bill of materials. Think of this as an incredibly detailed, hierarchical recipe for a single product. At the top is the finished end item, like a television. It branches down into major sub-assemblies: the outer casing, the screen, the motherboard. Those branches split again and again until every single microchip, wire, and screw is accounted for. Together, the master schedule and the bill of materials clearly define what to build, when to build it, and exactly how it comes together on the floor. Tracking thousands of tiny parts against a strict timeline is impossible for a human brain, so manufacturers rely on a software methodology called Material Requirement Planning, or MRP. The MRP software requires three main inputs to function: the master schedule, the complete bill of materials, and perfectly accurate inventory records. The software takes those inputs and explodes the requirements. It calculates your true needs by taking the total number of parts required for a job and simply subtracting the parts you already have in stock. Often, the software uses a lot-for-lot strategy. It instructs the purchasing department to buy the precise exact number of components needed for a specific production run, ensuring nothing extra sits around gathering dust. Finally, the MRP system generates daily reports. It creates a schedule of planned orders for the staff and issues immediate exception reports if a critical supplier is running late. For manufacturers in electronics hubs like Penang, this precision ensures sensitive components arrive precisely when the assembly line is ready. This allows the factory to keep production moving on schedule without wasting millions of dollars on idle components.
Thank you very much, brother.